Welcome. Good morning. Almost said good afternoon, but good morning, everybody. Hope you're having a good Microsoft Ignite conference. Today, we're going to talk about building Angular 2 applications using Microsoft TypeScript and Microsoft's Visual Studio Code. And some of the experiences that I have, I'll share with you on how it is to develop with Angular 2. And it's relatively hot off the press. Some of you may have heard it was released officially about 2 weeks ago or a week ago. So we're all here to kind of learn about Angular, Visual Studio Code, and TypeScript, and kind of what these things are. There's a lot of things going on in the world with web, and it changes all the time. The good news is, just recently, they did a full release of Angular 2. The Google Angular team has done something which I really appreciate and applaud them to do, which is they were completely open about how they developed Angular 2. There's a pro and a con to that, if you can think about it. Some companies develop products, and they never tell you about the product. There's just a lot of rumors and hints about it. And eventually, one day, they just kind of release it, iPhone, things like that. It just comes out. And that works, right? People buy it. They line up at the store. It's like a status symbol. You know, it's all, everybody's happy inside, unless they get rid of your earphones. Then there's companies like Microsoft and Angular, or the Angular team at Google. And what they do is they basically open the veils and say, we're building something, ASP.NET Core, Angular 2, Visual Studio Code, things like that, TypeScript, and say, here's how we're thinking about it. And you get to kind of see how it's baked along the way. Now, the good news about that is you get to learn a lot about it as it goes along. The bad news is, as they make changes in early alphas and betas, you suffer if you're going along with it. So it's the pros and cons. You got to figure out what do you like, what don't you like. I personally like it. There's definitely been times I've thrown things at the Angular team virtually to make sure that things didn't break, but I kind of like this world. But we've got only so much time in the day to deal with learning new technologies. So is it worth doing this? And who's actually looking at Angular 2? In fact, it's only been out for a week and a half, right? Well, one of the things the Angular team does is they measure the interest in Angular products. So this is a non-profit team, basically, where they just build product, Angular, that they use internally and that they use externally, and they get a lot of community support. So what's kind of in it for them here is they've got over 1 million people who visited their site in the month of October last year. That's 1 million people going to use it. They don't measure downloads necessarily because that's kind of hard to measure for usage because somebody might download it 10 times in the same day. So those are kind of difficult. Those numbers are way, way, way higher. But then if you look at where Angular 1 is this year, and I just took this measurement, they're about 1.2 million. So they've actually increased the number of people coming to use Angular 1 over the last year, just slightly, a little less than 10%. But where do you think Angular 2 is as far as the number of visits right now? About half that. That's pretty impressive for a product that just came out in the last week. There's a lot of people already using it in production, and there's a lot of people really interested in kind of moving forward with this. And hopefully today you kind of get an idea of why people are doing that. So it just came out. Let's talk about one of the big reasons Angular 2 is designed. Effectively, it's fast. It's really fast. One of the problems with Angular 1 was that it was developed 5 or 6 years ago now. 2011, I believe, was the first commit in their GitHub repo. And 5 years in the JavaScript world, that's like a generation, right? In the web world, those things move fast. Think about what phone you had in your hand 5 years ago. Probably nothing near what you have now. Things changed. So they made a lot of changes, and they rewrote from scratch to be much faster and also to compete with other things that are out there. And they did a good job there. They also made it much smaller, which means they're really targeting mobile devices as well. So let's take a quick look at what that means to us. Our app might be this big. However big it is, we've got all of our code in it. We've got Angular, we've got to pull down, all these different JavaScript code bits. Well, then we now have this thing called offline compilation with Angular 2, where basically what we're doing is on the server, we're running Angular's compiler on its own code. This is something that normally happens in the browser. They're processing all the templates on the server, and it does two things for us. It makes the code a little bit smaller to bring across the wire, our code. It also pre-processes the HTML templates, and then that code that Angular wrote to do that work no longer has to travel to the browser. So there's now less that has to go to the browser, and when it gets there, it doesn't have to go through that compilation process in the browser. Because as you can guess, on a server, it's faster than the browser. Then, before they send it across the wire, they do something called tree shaking. It's one of my favorite terms. Kind of visualizing a tree and stuff falling out, right? Like a money tree. Wish I had one of those. So in tree shaking, what happens is everybody writes projects where they have dead code. If you ever looked at a project and somebody has functions which aren't being called, objects that aren't being used, etc., well, wouldn't it be great if you could write something that tree shook it, shakes out all the dead code and drops it out, and therefore you don't have to bring that to the client either. That's extra weight. It also tree shakes features of Angular that you're not using. So Angular is this big, and it says, hey, you're only using these things, but after tree shaking, it drops the things that it doesn't need anymore. So that's cool. Now we're getting smaller. And ultimately, we get our application, which we use minification, and we can gzip it, and we get it down to tiny little bits and bring it across the wire to a mobile device or a web browser. So in the end, we're getting a lot smaller apps for our build process. And to get an idea of kind of where these things fit in the world, Angular and TypeScript, I did a quick chart on Google Trends. Now, I'm not a big fan of stats because stats can, really be used in any way to make your argument or against an argument, but it's nice to get something at least to say, all right, am I investing my time in the right technologies? Right now in the web, there's 3 main libraries still. Some of you may have heard of something called jQuery before. Yeah, so jQuery revolutionized what we did in the web. Everybody uses it. I still use it. There's reasons for it to be there. It's definitely declining. I don't know what those big dips are. I think maybe Christmas. Maybe nobody searches at Christmas. But I think that's basically a general decline because people aren't adopting new stuff with it, but it's still out there considerably, and we've got to support it and deal with it. Then you've got the red and the blue lines. The blue line is Angular, and then the red line's React. I didn't put any of the libraries on here because all the other ones are basically a flat line at the bottom. These are the 2 that have dominated the Google Trends, the Stack Overflows, the GitHubs, all those kind of places. These are the technologies going there. And as much as people say that React has overtaken Angular, it hasn't. There's a ton of interest. It's tremendous in React. But Angular is also tremendously popular. So I think the time investment in either one of these is a good choice. TypeScript is something else that's interesting. People have been complaining about JavaScript since it was invented in 8 days. I mean, why couldn't he just make a better language in 8 days, right? Anybody could do that in 8 days, right? So instead, people have been looking to do different things. Dart is another language that the Google team likes to use sometimes, some Google teams. And then TypeScript is one that Anders Hejlsberg and Microsoft created. And then CoffeeScript is another language that came out too, to kind of make it easier to deal with JavaScript. You can see kind of what's happened with these different libraries over time. TypeScript kind of started off a little bit slow, but then it really peaked up about 1.5 years ago. And the event that caused that was the Angular team decided that they wanted to make their own language called AtScript. That's all we needed, was just another language to learn, right? So they said, let's go create AtScript. AtScript's going to be this new language that we can use to write instead of JavaScript. It'll make life easier for all of us. And then they looked at the TypeScript team and said, hey, that's like 98% of what we did. And they're like, why don't we just talk to Microsoft? And first pigs were flying and cats and dogs were getting along, and it was great. Within a couple of months, AtScript died. The Google team now works and meets with the Microsoft team regularly, and they adopted TypeScript for writing Angular 2. Not just for us to use it, but they wrote Angular 2 in TypeScript. And since then, that kind of just spurred the whole fury of people using TypeScript. So I think the investments in these are pretty well founded. And we're going to show today a little bit more about these different languages inside of Visual Studio Code. My name's John Papa, and I'm a Google Developer Expert, a Microsoft MVP and RD. And I do a couple Pluralsight courses on the internet. And I also author the style guide and the tutorials on the Angular IO website. So if you want to check those out, there's free tutorials as well. So let's talk quick about Angular. When we're coding Angular, we have a couple choices. We can use ES5, ES6, ES7's coming out, or TypeScript. Now, first, to understand a little about ECMAScript, that's what ES stands for. That's JavaScript. Along the way, JavaScript was taking years to come out with new versions. Well, the web was moving really fast, and JavaScript just wasn't. So instead of naming them 5 and 6 and 7, they decided now to name them after years. And that's OK. But the hard part is ES6 is ES 2015. ES7 is ES 2016. So when you start looking at the numbers, they're kind of one off, which makes it hard to talk about. But you want to keep an eye out for these. Every year there'll be a new version of JavaScript. The browsers are adopting them. They're all evergreen now, even Microsoft's browsers. So they always adopt the new stuff. And they're looking at how we could write this stuff to use it. We could use the next version of ECMAScript, but if it's always changing every year, how do we keep up with the changes? That's where TypeScript comes in. TypeScript makes it easy so it's always looking ahead to what ECMAScript is doing. So in Angular, we can use any of these. ES5 is the older browser compatibility. Like you're writing an IE8, that's probably a great option for you. There's no compilation with ES5. With ES6 and ES5, you still have no types. You get all the new features of JavaScript, but you're not getting types, and you're not getting some of these decorators and other features that you'll see today. In TypeScript, you'll get that. With TypeScript, you're going to get all this stuff, and any JavaScript is valid TypeScript. That's the biggest reason I jumped to TypeScript. CoffeeScript and other languages, they morphed what JavaScript was to make it easier to use and to do things. But with TypeScript, what they did is they said, we'll start with JavaScript, and if you copy any JavaScript you have into a TypeScript window, it'll work. So they took that and they made it a superset. ES6 is a superset of ES5, and TypeScript is a superset of all those. So this is kind of like future-proofing your code in a way. Now we've got TypeScript, which we can write in, and then everything we're doing is basically looking a little bit ahead of what ECMAScript is doing. And I heard an interview with Anders Heilsberg, who's here this week. Definitely catch up with him if you can. Great guy. One of the things he was asked in this interview was, have you ever adopted something in TypeScript that was then taken out of ECMAScript? Like they're looking at putting it in, so you put it into TypeScript, and then they took it out, and you were in trouble. So now you have to support dead code. And he goes, no, we didn't. It's never happened to us. And the reason for that is there's actually a very specific process for the ECMAScript team to go through to adopt new features. And once it gets to a certain category, I think it's category 3, where they basically say, we want this, this is how it's going to work, this is what it's going to look like, it just isn't done yet, that's when the TypeScript team puts it in the TypeScript. Which means you're still getting it in advance, but you're getting stable code, which is awesome. I think it's a great, great idea. So TypeScript, good idea. Angular, good idea. Let's talk about what we can do with Angular. There's some pretty basic concepts in Angular that other technologies have as well. If you've done .NET, if you've done Java, you'll see these kind of concepts. You can have services, basically a class that just provides something for you. You can have components. Those are your widgets on the screen, things that actually visually entertain your users. HTTP calls. You got to go get data somewhere. Most of the apps I write have data. Events, we can call off events. We can do data binding, so we don't have to worry about pushing and pulling data back and forth between our screen and our code. So let's start talking about components. A component is something that's visual on the screen. And the anatomy of this thing is we're going to first start by writing some import statements. How many of you here have written TypeScript before? OK. And keep your hands up. How many of you have also written C#? Everybody written C#? OK, most people here. An import's basically a using statement. You're saying, go get this other thing so I can use it, please. That other thing in this case is Angular knows about a component, so it goes and gets it. And we also have a service we're writing here called a vehicle service, which we're going to get, and that's our own code. So here, we're going to import the other module, and then we're going to use this @ sign. This is a decorator. If you've done C#, it's like an annotation. They have those in Java as well, lots of different languages. It's metadata about a class we're writing. So in this metadata, we're telling it the name of the selector is story vehicles. That's going to be the name of the HTML tag that you can put on a page and that this whole thing will represent. And then there's a template URL pointing to the HTML for this, because remember, this is going to be TypeScript code. So the metadata is going to describe it for us. And in this case, our component is just a class. We create a class, and it has a list of vehicles. It's an array of vehicles. And the nice thing about this is just a class. There's nothing special about it. It's a class that has an annotation or a decorator giving it some metadata. So how do we use these components? Let's say we've got this application. We usually start with one component. That's the whole app. And we create a hierarchy of these. We might have some kind of a header on our page. Then we might have a nav component and a footer. And then maybe on that other side, we want a content area. All these pieces can be assembled. And we can decorate and create our application with these components. Before I actually write an app, I like to take the app, and I like to write the components, and figure out, literally with like a Sharpie marker on a piece of paper, where are the different things on this screen that my designers created? Can I draw lines around components that I could reuse? Or components that have different, distinct sets of functionality. And then I draw that out, and there might be multiple levels of hierarchy in here. And then we can go define and design these different components, because after they're all done, they're all living inside this app component. So how do we get the component to start? One of the things that we often take for granted once we know a technology is if we go to look at a new technology and we give it to our friend to do that, they're always looking for, okay, there's 50 files in here. Where's the one that starts it? So I can kind of walk through that process. Well, in Angular, there's a file we call main.ts. You can call it whatever you want, but it's just a convention a lot of languages have had. And we want to have this as the entry point for our application. This is where we start. And these are the 3 lines of code you need. First, you have to go get Angular's platform. The reason that line's there is because they're now designing Angular as a platform so you can write it for the browser, for mobile devices, for Electron, for other things as well. So you pick the platform you want to be on, and then you tell it, where is my code? Where does my code start? That's app module. I usually call my root module app module. So I say, OK, use this platform to bootstrap my module. And that's it. All right, so if we have a component called story component, inside of this guy, we've got our story characters, and our favorite character, Han Solo, was there. And this guy is where we put our logic. So our logic goes inside of a character component. And then we've got our HTML. What are we going to show? Notice we're just binding to this name property that's up above. So that's what's going to be rendered on the page. The component has a TypeScript file. It's got an HTML file. And then we have to put it somewhere. So maybe inside of our index.html page, we actually have this component, and we just put in the name of the tag that we referenced, that selector up top. So that selector tells it, go get that guy right there. And then he's going to say, go ahead and render that HTML. This is how this tree works. Now, the interesting part is on story character loading demo at the bottom, story character is not a valid HTML tag, right? So when you first render, while it's trying to render, like on a splash page type thing, anything in between those 2 elements is what's going to show on the page. So it's going to show loading, ... and then once it renders, boom, it's going to replace that with your actual HTML. Cool. Let's take a look at a demo. So if you go to the Angular.io webpage, and that's up here at angular.io, they have a quick start, which is right here. And you can follow through that, and you'll see kind of how to create a basic, simple app. And then there's a tutorial, which I helped author, which is a couple different steps to building what we call the Tour of Heroes. It's a fictitious set of heroes that are out to save the world. And you're building an Angular app to kind of show these heroes how they can find work. Because heroes need work, so it's like a job board for heroes. And the end result of this, which you can download or run it online, is you get an app like this. And in this app, we end up with a dashboard, which shows me my top heroes. And then we've got a list of heroes over here, which we can then select or delete, do whatever we want with. And we can also search through. So I can type in different heroes here. I can also do type heads for other ones. There's a rubber man. That's awesome. And we can change these guys to anything we want. On this page, there are multiple sets of components. There's an app component, which is the whole app. There's also a component for each of these different views. The dashboard and the heroes both have different components. So we show our dashboard, we show our heroes. We have different components for the details, too. When I select Narco, here's a detail component. Let's look at the code for a minute. So inside of Visual Studio Code, let's go over here. I've got my application, and inside my app folder, you're going to find first that main.ts. Remember I said everybody looks for where do you start? That's where I start. So we found main.ts. I'm going to go ahead and launch this app module. And then let's go find him. Now, this is what's cool about Visual Studio Code. I'm holding down my Command key, and I hover over app module, it shows me a preview of what it is. I can also click on it, and it goes right to it. I don't have to go figure out where is that file. Make this one notch smaller. There we go. So in this guy, this is like our manifest for our application, our app module. We'll learn more about this guy later. The important part is, which component do I start with? That's line 35. We're going to start by saying, go get the app component and launch that up. We'll come back to this guy in a minute. I'll click on app component. And here, we have an inline template for our app. It shows the title of our application, and it shows some navigation. I have a router link that goes to dashboard and one that goes to heroes. Router links are the way we navigate to different components. So when somebody clicks on that, it's going to go find that other component, and it's going to load it onto the screen. So cool. Let's go look at the dashboard component now. So another thing you do in Visual Studio Code is you can hit Command-P and type in dashboard like this. Let's say there's too many of them. I could type dash.ts, and it helps kind of lower that down too. So inside a dashboard component, we can see that we've got our My Dashboard selector. It's got my HTML over another page. Let's go look at that. I'm going to go ahead and get a list of top heroes. I'm displaying the top 4 heroes on my page, and it's got an array of them. So it's going to get a list of heroes, and we're going to say for every hero of heroes, go ahead and display the hero's name. So where does that come from? Over here in our component, we've got a list of heroes, which we're initializing to nothing. And then you can see in the ng on init, line 22, we're going and getting that list of heroes from somewhere else. We'll look at that in a bit too. And then when that list comes back, we set it to a local variable called heroes. And you can see I'm just doing a slice to get my first, or actually my 2nd through 5th heroes. Just a quick way to show how a component can encapsulate its logic. Inside the dashboard, we just want heroes to show. We're showing this right here with those 4 guys on top. We just wanted the logic to get those 4 guys, show them on the screen. So the information to go get the data, like how does it get the data? Where is that API? Is it in Node? Is it in ASP.NET? Is it in Java? Is it in the cloud? This component has no idea where that is and shouldn't care. The component just says, somebody will give me the data, I will put it on the screen. That's my job. So the component is very small. And the way you start a component is there's lifecycle events, just like we have in lots of other technologies. Our lifecycle event, we implement this interface called onInit. And then we say, all right, in my ng onInit, that's a function that Angular 2 looks for and says, any code inside of here is going to run when I start it up. So if you want to go get the data or do something like that, you can do it in this code. There's also ways, if you really want to, that you can try to get data before the component actually loads using the router. So if you wanted to do some authorization checks, you can do that too. We'll take a look at that. All righty. So inside there, we saw more than just components. We saw templates too. The templates are going to be basically our HTML. It's what's shown on the screen. That's what's going to tell the browser or the mobile device what to show. A template might look like this. We use this ng4 thing quite a bit. It's going to loop through a list, display the stuff on the screen, and we're good to go. So in this case, we're using a directive called ng4. That's like a repeat. And we're interpolating the value of characters.name. I love technology because we get to make up words all day long. Interpolate's actually a word, but it still sounds really cool. I say it at home. My wife is like, I don't know what you're talking about. And I'm like, you know what? You're right. I don't either. But in this case, we're interpolating. We're taking the name, character object, .name, and we're just rendering it on the screen. It's just a quick and dirty way. Some people call these mustaches, handlebars, because there were technologies that did that a while ago. And then we can also have nested components. You remember on the dashboard screen, we had a nested component. We had a search component at the bottom. We could actually search for our heroes. So we can embed components in other components as well. In this case, we're embedding a my character below. So as you might guess, the top is showing a list of characters, and when I select one, what should happen is the selected character property should get set. And when that happens, it should show that bottom component. The ngIf says, if there's a selected character, show it. Otherwise, do not render this. So the templates are just HTML. We use directives where we need them, as we need them. And we use this binding syntax. So there's a funny character on this page. There's a square brackets around the word character. Remember that. I'm going to show you that again in a little bit. The key here is the component needs to connect to its template somehow. So the way we do this is we can link the component through a property called template URL in our metadata. This is why that metadata is so important. How do you associate the code with the view? And the way we do that is we use template URL to tell it where is my HTML. Now, remember that optimization steps I mentioned really early on? Part of what that does is it takes all the HTML and shoves it back into the file when we're done and optimizes kind of how the binding syntax works. But when we're coding, we don't want all of our code in the same place. We want to separate our HTML from our TypeScript and whatnot and make it easier for us to read. So that's what we do here. We say, OK, here's our TypeScript. Here's our HTML. And remember, components can have templates, which can have other components too, just like we saw with the nested components. So we might have something like a root component, our app, which has a template, our HTML. And inside of there, he might have some other things, like a child component, which has its own child template, and another one. Maybe it's like a nav and a footer. And then those components can also have other components, and so on and so forth. This is called a component tree. One of the reasons they chose the word component is it's very similar to the theory or the ideas of web components, which are not officially standardized entirely across all the browsers yet. So these are visual components that we can see on our page, and they can all nest each other and relate to each other. Makes it easy to build applications. And we also saw metadata in that file. And the metadata is what links the template to that component. So we've got our template and component, and we've got metadata between there that kind of puts the glue in between them. That's how we pointed to the HTML. We can also point to our CSS. Now, whenever we create a component, we have to tell Angular it exists. What do you think would happen if we create a component called John, and the selector for HTML was John? What do you think your browser would do if it saw an element called John? Nothing. It looks at it and goes, I don't know what that is. It doesn't even error. It just says, boop, moving along. Well, so when we create our own components, like story component or characters or heroes, we have to tell Angular to let the browser know this is a thing, and this is how you should perform its operation. So the way we do that is in advance, we tell our root module, this ng module thing, that we're going to declare our components. So here we've declared our characters components. So when it sees my character list and my character, Angular 2 will now know, I know what those things are. Don't skip them. Let me do my thing. So we declare our components to the application just once, and then the app knows what they are. Now, something that's interesting is there's a lot of little things that Angular gives us, like that ng-for and the ng-if. So those things the browser doesn't know what are either. They're actually in a module that Angular gives us called the common module. So when we import this browser module, it's actually getting that common module so we can use those features too. So we don't have to worry about the Angular stuff. We don't have to tell Angular about its own things. I mean, it makes sense. Angular should know what Angular is, right? You would hope. We have to tell it the things that we write. So let's take a look at this metadata a little closer. Here's a component which has got a little bit of everything in it. In this component up top, we've got that decorator that I mentioned. The decorator is that @ sign. That's where they got @script from, by the way, when they started coming up with that. So the decorator is that place that we define our metadata for our components. And then our component actually begins at the class. It's usually important to export this class. This means that other things in your app can use it. It's like making it publicly accessible inside your application. So that's our class, our component. What else is in here? We can point to our template URL and our style URLs, plural. The latter is because we can have multiple CSS files. This is a very small, subtle, but very important point. We build a component, we want to have CSS for it to style it, to give it behavior, animations, other things like that. What if we created a style for this component, but we didn't want it to affect any other component? Could we do that? Because they're putting the CSS in this component, we can. It gets basically scoped to this component, so we don't have to worry about somebody wrote a style here called something like table. And then somewhere else in your app, somebody decides to use a table class as well. And what does CSS like to do? Cascade its style sheets. All of a sudden, your blue app is looking purple, and someone's like, what happened? So things like that can really run into each other with apps, especially when you're pulling in third-party libraries that might have their own style sheets, or you pull in a second-person team members' code. So what we're doing here is we're saying styles, these guys are going to be scoped to my component. Makes it super awesome. And then we tell the component, in some cases, if it has any services that we need to use. There's actually a better place to put these, but this is one of the options, and we'll talk about that too. And then down below inside the code, we use dependency injection to inject our character service. So if we want this characteristic component to go get data somewhere, I wrote another class called a service, and I just inject it in the constructor. Angular goes and figures out where it is, and it provides it to my component. And then I can do other things like set properties, or I can go ahead and I can do actions like methods, like create a select method that I can bind to my screen so somebody clicks on something, it selects that character. So all this metadata puts things together so we can take a look at this. The last piece of the kind of the core pieces of Angular I want to show before we do the next demo is data binding. This is one of the things that made people really jump on Angular in the beginning. When Angular 1 came out, you got to remember the mindset that was happening. Some of you may have been doing web then, some maybe not. It's been a growing trend. When I got into doing the web, one of the things that really held me back originally was that I was so used to .NET technology like WPF and remember Silverlight, anybody? Yeah, so. By the way, back home they call me the guy who killed Silverlight. So that's not true. But those technologies and lots of others had data binding. And data binding years ago was a terrible thing because the way they did it was awful and performance was bad. But with things like WPF and Silverlight, it was so cool. We could have 40 fields on a screen, have an object inside of our code, and just tell it, look, point at that object. Boom, data appeared. And somebody types on the screen, and the data goes right back to the object. Before that, and what a lot of people in the web are doing is using jQuery to say, go get my 40 fields from a database. Now, go through that list property by property, and for each property, okay, there's first name. Now go find the element on the page that has an ID of first name and stick the value in there. And they do that for each property, 40 lines of code. And then, when somebody presses save on the page, they'd go the other way and say, go find that ID on the page of first name, now stick it back in the object. Another 40 lines of code. And that kind of got really mundane and One of the things that Angular did in another library called Knockout.js, which were really cool libraries, they came up with ways to do data binding for us, to say, look, as long as you name it this and you refer to it in the template with the same name, I'll match them up for you. So let's see how Angular 2 does data binding. We have a DOM, we have a component, and we have 4 different ways to do data binding. First, we can do interpolation. Just render this value on the screen for me, it's read-only. Easy. Then we have one-way binding to a property. We use the square brackets to define that this is a binding expression one way from our component up to our DOM. And we can bind to any HTML property. Any HTML property. Now, one of the things with Angular 2 that was interesting was I had forgotten a little bit of HTML for a while. I actually had to go back and look at the spec to figure out which properties it had, and there's just dozens of them. There's so many of them. But what's cool about this is now there's no more like making up imaginary Angular terms to actually do bindings on the screen. They're just saying, forget it. We're not making our own functions to hide this. You can take any HTML property and bind to it. Class, style, anything. So that gets it on the screen. But what if you want to get it back? You use parentheses to wrap an event, like click, on blur, on focus, whatever event you want to do on mouse move. And then you can fire a function back in your component. Now notice we have one way in either direction. There's always one way. One of the reasons Angular 2 is much faster than Angular 1 is it uses something called unidirectional data flow. Just a big long term for saying it only goes in one direction. So it only goes from component to a DOM or DOM back to the component. The reason this is important is because in Angular 1, they actually did it both ways. So anytime you changed anything in Angular 1, they had this thing called the digest cycle, which is like your stomach churning on bad Mexican food or anything else, right? It's sitting there going, ooh, I got to keep crunching this thing down until I figure out what it is. Inside of here, if you set a property in Angular 1, it would actually run through the digest cycle multiple times till it checked every property till they all stop changing. Because one property might be linked to another and another and another. And that could really slow you down when you had a lot of these. Go Google digest cycle if you haven't seen this. In Angular 2, they said, let's get rid of that. Let's make it go in one direction. That way, we know where the source of truth is. We always start at the bottom, the component, and go up. Once we get to the DOM, it's done. One time, one direction. Same thing with events. Start at the DOM, go back down. OK, I lied to you. There's actually something that goes both ways. But they helped us out here. What they did is they wrote their own thing called ngModel. And all it really is it combines the two ones above it. It combines, I want a property, an input text box. I want it to go from my component to my screen. And I also want some kind of an event when they type in there, like on key up or on change. I want it to go back down to my component. We could have written both those lines of codes ourselves. To say, OK, we'll send it up, then we'll send it back down. Well, if you actually wrote that code out, it gets kind of long after a while to keep writing this. So they wrote a little directive called ngModel. And they said, let's make them use both characters, because it's just fun, because we can. And they call this the football in a box, because that's what it looks like. And that's how you do two-way data binding. So our template, again, has a component with metadata between it. And now we use our property binding on the way up, and we use our event binding on the way down. So the advantage of this unidirectional data flow is, if you've ever integrated like a jQuery UI widget or anything with Angular in the past, with Angular 1, it's not fun because after you pulled in something from some other library, like jQuery UI or Kendo or other things, you'd have to run the digest cycle yourself because Angular didn't see it because it was trying to figure out what that data is. Don't have to worry about that anymore. You can integrate with any third-party widget library now. No more $apply, which is the function you call to say, OK, now that you integrated with somebody, call apply so I can see it. Doesn't exist anymore. No more repeated digest cycles. The Angular team used to say 2,000 watchers on a page, 2,000 bindings on a page was the maximum. I actually saw an app for a very large company I worked for which had 100,000 of them. The screen was taking 70 seconds to load. And they asked me to make it faster. I said, put less things on the screen, maybe? And they said, you're nuts. No more watchers. There's no more things watching things in the background with this because the data goes in one direction. Think about all the things that go away when you have unidirectional data flow. And no more performance issues with digest cycles, which was a common thing I was often hired to do, is come help fix those. So I'm out of work. Anybody looking? I'm free. So one-way in interpolation, we already saw that. We can use it for source and href. If you did Angular 1, remember, you might have to do ng href or ng source. They're gone. Don't have to touch them anymore. You just put an expression in. You want to bind to a property? You just find that property and bind to it. Source? OK. Put the square brackets around it and bind to a property in your model. You want to bind to your own property, like maybe make your own component. It's got an input property called vehicle. Just bind to it. Very easy to set up binding expressions. If it's square, it's a binding. So that's an element property. This is our component property. And that would be a directive that Angular gives us to help do with CSS classes. We can write to any property or event that the DOM exposes, but not attributes. This is important because it's something that if you haven't done a lot of HTML, like dove into the spec, you might not realize sometimes the difference. Looking at an HTML element like a div or an input, something like source on an image, that's a property. But what if you see something like an ARIA label for accessibility? That's actually not a property. That's an attribute. Well, because it's an attribute, you can't bind to it. Oh no, the web's broken. What are we going to do? So what we can do is you actually say adder dot and then the name of the attribute, and you can bind to it. So they gave us a way to get to anything that wasn't a property as well. In events, we can bind to like click, changed, on focus, on blur, whatever you want. You just use those parentheses like this. So anytime we do that, we just call our function, and we can pass values in if we like. And then we get the football in a box. Two-way data binding. We say, all right, we put the parentheses there, and then we put the square brackets around it. The reason I like calling it a football in a box, too, is because when I first started doing this, like the first couple of weeks, I used to put them in the reverse order and wonder why it wasn't working. So it's not a box inside of a football. That doesn't make any sense. It's a football in a box. And that gives you the two-way data binding that you can use to go up and down. And you usually use these on inputs. So here we've got our built-in directive called ngModel. We use that a lot with forms. So if you want to use ngModel, it comes with the forms module. Up top, we're going to import this forms module from Angular. It gives us this feature. This is cool. Angular said, we're not going to shove every feature we have down your throat. Instead, you pick and choose what you want, and we'll give it to you. If you're not using forms in your app, which you might not be, don't bother importing it. And that's less code that goes to the browser. It's less code you have to churn on. But if you are using it, go ahead and import forms, and then you can use that inside your application just by telling it, import the forms library. Now we've got our common library from the browser, things like ngIf and ngFor. And we've got our forms. There's other libraries too, like HTTP module, if you want to use HTTP, or the router module, if you want to use routing. If you want to use Angular Material or things like that, like third-party widgets, you can pull in the Angular Material module. All right, so let's take a look at some data binding. By the way, all these examples, if you go to github.com/johnpapa, you'll find all these Angular 2 examples. You can also find many of them on the Angular I/O website. So if we go back to our hero list, and I click on our heroes, we can see a list of heroes right here. And let's select somebody like Ray. And down at the bottom, you can see there's Ray. She's my hero. And there is my input box. Let's take a look at what that looks like inside the browser. I'm going to inspect him. And over here in font size -7. All right, now let's select him again so we can find it. We'll go a little bit bigger. All right, so what we've got is we've got an input box, and it's got a couple special things hanging off of it. Notice that it's saying ngReflectModel is Ray. That's the value that Angular's sticking into that to get the value out after we did the ngModel. It also has this ngContent thing. This is the styling. Remember I mentioned there's scoped styling with Angular components? Every time we have component CSS, it puts that CSS and scopes it for the component automatically for us so it doesn't bleed out into the rest of the app, so I don't get red and blue and green all over the place. Now we take a look at this code, which is here, and that was the hero details. You'll notice I've got an input called hero. That input is a binding that I'm passing into my component. And then once I get that hero, as you might expect, that property called hero should show up in my detail component. And here he or she is right there. And notice I've got my ngModel. What happens if I change this to value? Value is a property, right, in HTML. If I change that to value and it reruns, I'm still seeing Ray or Rubberman or who else it might be, and I can change this one to Obi-Wan. But when I save this, nothing's actually going to happen with it. Notice it's still Rubberman right there. That's because in my code, I just changed it from a two-way binding to a one-way. It's going into the input box, and even though it looks like I can change it, I'm really faking it out, and I'm not sending it back to the components. So instead, what I could have done is I could have done a value, and then I could come over here and said, OK, on key up, and then I could have called a function that says blah, 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 blah. Go ahead and take that value and shove it back down to the components. This is why they have the ngModel. Just give me an input, bind it to a value, call it a day, I'm out of here. So that's how we bind to a specific value. What about these buttons? Here we're saying click, and we can do go back or save. Let's go back up to the list, though. We've got our heroes component, and we've got an ngFor up here in line 3. Notice I'm listing my list of heroes, and then I'm clicking with a binding, and I'm calling an onSelect. And in the onSelect, I'm passing in the hero. So I can pass values in and out, too, with my functions and bindings. Makes it super easy to wire my template to my TypeScript. And then in my TypeScript, I've got this onSelect right here, and I can just set that selected property to a hero. And that's why when I select somebody like Mr. Nice, down at the bottom, I can see Mr. Nice's detail, or tornadoes, or magmas, or etc. like that. So data binding, not too hard and very, very powerful. We already talked about the next topic, so I'll kind of go through this one relatively quick. we looked at a bunch of things like ng-for and ng-if. There's things that we might want to take advantage of that we don't write our own code. Like, what if we want to show this vehicle only if you selected it? It'd be nice to have a way to do that. So we just call ng-if, and it's got a star in front of it because it's a structural directive. Any directive that actually changes the DOM on you, that changes the structure, will start with a star. What it's actually doing under the covers is it's using the template tag, which is an HTML compliant tag, to create a template for what's inside of there. So here we're saying, if you have a current vehicle, show it. Otherwise, get rid of it. Don't show it in the DOM at all. Takes it out. If you wanted to hide something, but not remove it from the DOM, you could just do style.visibility equals and then some function. Remember, you can bind to any HTML property. Style's a property, and it's got another property called visibility. So we could hide and show as well. So here, if that value is truthy, which means it's got a value in it that's not like false or undefined, you're good. ng-for, we can loop through our list of characters. Again, a structural directive that's creating a template for those li tags. It's going to show a number of elements that we have on the page. We can sort them if we want to, do other things. We go bind it to this character property that's inside of our model, our component. And we use the let keyword to declare the local iterator. So we're saying let character become one of these characters. And then we'll iterate over it and create a list. There were something like 80, 70 different directives in Angular 1. Over 40 of them that I've confirmed have gone away in Angular 2 because we don't need to use all these ng things in Angular 2 for things like style, for class, for visibility, for source, for href. They had a different directive in Angular 1 for all these things. And in Angular 2, they said, you know what? HTML has these things already. Why don't we just take advantage of what's there and let you put the square brackets around them? The only time you've got a directive that you got to deal with now is when you need to do something just a little bit more that HTML isn't inherent with, like an ng-for. You want to loop through things? We're going to give you an easy way to do it. An ng-model, a way to do two-way binding. And you get these by pulling in that common module that we talked about earlier. So a common error you'll see in Angular is when you start an app, if you don't pull in the common module, you will get an error like, I don't know what ng-if is. So if you see that, yeah, I got to go get the browser module, which pulls in the common module. And then we import it right there. So we just saw those directives too. Now this is the thing I said I was going to come back to. Every application needs at least one ng module. It's a way to organize your application into cohesive blocks of functionality. We do this in a lot of things. We do this with namespaces a lot, and .NET with C# too. The reason these modules are important to Angular, and this is actually a late addition because they're trying to figure out the right way to do it. Think about if you want to load your application on demand, lazy loading. You only want to show certain parts of the app if the user goes to that part of the app. Let's say your app is really big. You've got 100 different screens, 1,000 different screens, broken up with different sets of functionality. If you want to make it such that every time they go to a screen, because half of this app they'll never actually go to most of the time, when they go to those unused, infrequently used places, it lazy loads. You have to have a way to put a box around that area so you know what else does it need besides that component. Does it need a service or something else? Does it need 3 components? Does it need my heroes area, my admin, my login, customers? So you can create these boxes around your code to group them. And that allows you to do things like lazy load them on the fly. Or put security around them if you don't want them to get to an unauthorized area. So it's effectively a fabricated way for us to define areas of our application. So in a module, we might have a bunch of components. And we might have services for those components, like heroes, hero details, hero editing, and then a hero service. And all you do is you create a class and you decorate it with this ng module, decorator. Metadata, again, just like an annotation. The roles of these things. We'll import other Angular modules. We saw where we're importing like common module or forms. We can identify components or pipes or directives. Pipes, not pipes, but is that how you hold a pipe? I don't know. Probably not like this. Pipes are like filters for your code, like formatters. If you did Silverlight, like I-value converters. We can identify those for the app. We export the features that the module should use, that module. And then we provide services to our injector, the dependency injection system, and you can eager or lazy load them. You define how you want it to go. You can have part of the app eager load and part of the app lazy load. And every app has to have at least one module. If you're building a small app, it could make sense to just make one module and be done with it. That's it. I got a module, call it a day. If I don't need all that stuff. So here's a root module that you'll find in a lot of apps. Here, we'll import anything we depend upon up top. The ng module says, I need the forms. I'm using ng model. I want to use it. I want to use ng if or ng4. They're inside the browser module. Pull them in. I have this component in my app called vehicles component. So you're declaring it so the browser knows how to render them. I have a service called vehicle service that I need to use. That's going to go get my data from my vehicles or my characters or my stories or any other data I've got. And by providing it at this level, everybody in this module can use it. Remember I mentioned there are two ways to do providers? If you put the provider at the module level, everybody can use it. There's one root injector in Angular, and this makes the services easy to access. And then in one module, just your root module, you'll tell it what to bootstrap. You might have other modules in your app. You don't bootstrap everywhere. You only bootstrap in one place. That's the starting point of your app. Say, OK, when I start up, this is what I want you to show. And then you define a class. And quite often, the module class has no code. Notice that. It's effectively just a way to contain everything in our app. It's a manifest of what our module contains. So cool. We saw a model before. We'll take a quick look at that again. So in the Tour Heroes app, we have, if I go to app module, there's the module we just took a look at. And you'll notice I have a couple providers. The first provider is Hero Service. And then I'm doing some magic in the next two lines. I'm actually faking HTTP. So every time I go get data, I'm actually using an in-memory database to go do it. But this is where you list your services for your application. So that module defines all the different declarations. Here's the different components my app uses, and that's the rest of my providers. Very simple. So we talked about services. This is probably the hardest part of Angular to learn, Angular 2. The way services are gathered are easy because it's just a class. In Angular 1, we had factories, services, providers, constants, and values. There are 5 different types of services, and it drove everybody nuts. And I think one of the most popular Stack Overflow articles was, which one do I use? And the answer most of the time after I got tired of answering it was, just pick a factory and be done with it. In Angular 2, guess how many of these still exist? None. Trick question. They're all gone. You just create a class. If you want to create something that goes and gets data or does logging or is an error handler, some kind of a service class, just create a class. You're done. It got rid of all the Angularisms and just said, we'll create a class and call it a day. So how do we do it? We create a class called vehicle service. And it says, get my vehicles, which I'm hard coding here. And it provides something of value. It could be shared data or logic. Some examples are like exception handling, logging, message services, things like that. We just name it what we want and we use it. That's the easy part. The hard part is, how do you get it? Dependency injection is an important part of Angular. So Angular has this thing called an injector. There's one at the root module, and there's one at each component level. The injector contains things like services. So we have to ask the injector for a service, and it tells us, oh, yes, I have that thing. And if it does, it'll give it to us. So inside of a component, we can say, please, Mr. Constructor, inject in the thing of type vehicle service. Types at work here in TypeScript. It says, OK, I know what a vehicle service is. I'm going to go to the injector. If the injector knows what that thing is, it's going to either give me the running instance of it, the singleton, or it's going to create a new instance. So then we get our vehicle service. And then our vehicle service can also inject things too. So we can have a vehicle service that injects HTTP or provides information about it. Now, the key here is you need to provide the service to the injector. You've got to tell it about it. That's why that provider statement was there earlier. So remember, we had a providers inside of our ng module. Here, we're providing the vehicle service, so it's available to the root injector. And here's just a visual of how that works again. We've got our component with our injector, and then we can have multiple services in there. Cool. So these are the kind of the keys of Angular on this. I wanted to leave some time for some questions too. All these slides are available as well, plus all the code samples. If anybody has any questions, feel free to come up to the mics and you can ask some. Otherwise, I appreciate you guys coming and hope you have a good week here. You know, it looks like the mics are off. Instead, why don't we just come up? Does that work? We got them? Okay.
Is there a resource for showing if you did it this way in Angular 1, how do you do it in Angular 2?
Yes, actually, there's a great resource for showing how you do things in Angular 1 on Angular 2. It's up on the Angular I/O website. Okay. There's a chapter on Angular 1 to Angular 2. Good question. Yes?
Is it in the injector, or is it the bootstrapper where you configure all of the services that are going to be injected? So I mean, like if you look at like Unity, you have a bootstrapper module where you configure everything, and that's what gets injected. Is that similar to what we're doing? Similar here?
Yeah. So there's a couple ways to inject things. If the question is how do you make sure it all knows about all those?
Right.
If you want them to be available everywhere, you provide your services at the ng module level, and then the injector just knows about them. If you want to scope those though to specific components, you can actually provide them in a component too.
So in a standard, I'll use Unity as an example. I mean,
okay, Unity.
You generally have a single place globally where you're doing that bootstrapping, and it configures every single service that service or component you're going to use, and that's how it knows about it. And
right.
So, are we doing something similar here?
Are you having a single place to tell the injector
exactly.
about all of the stuff?
Yeah. So
you can, yes. In many apps, that's exactly what you'll do. You'll tell the root module, here's everything I'm going to inject at some point in time. The reason I mentioned that caveat of you could do it another way is there may be places where you only want a service to be available in one place. For example, let's say you're building a login component, and you want to share that across multiple applications. The only guy using the login component service, the login service, is the login component. So you might not want to inject the login service at the root with everybody else. You might want to keep it with that component, so that way you can literally lift that code, copy it somewhere else.
Got it, understood.
Cool.
I have a question.
Yes.
How do you compose modules within modules?
How do you make modules within modules? Magic. It's magic. Okay. So what you do is you make your own ng module. When you make your second one, I showed the first one. When you make a second one, and the code examples I have should show one of these. What you do is you take that and you define everything in each module separately, and then you just import the module into the other. So remember the forms module? Let's look at here's a much more complicated example. This one has like 100 files in it, and I have a root module right here. In my root module, I'm pulling in browser and HTTP. Those are Angular things. Notice I have a login module. Where that's going is it goes over to this module here. So I've defined a small module, and you'll end up finding out that as you break your app up, all your modules are really kind of tiny, except the root module, because he's the guy who just pulls in other modules. If you don't do this in an app of this size, which really isn't that big, it's like 100 files, if I only had one module, I'd actually be importing like 100 things into that root module. By breaking it up like this, I've got a bunch of tiny little boundaries which I can just yank into the root app.
Also, the way that you have organized your code, so every module gets its own folder, and you put all the components and routing and services in the, I mean, is that a best practice?
Yes, so the question is, do you put a module inside of its own folder? Yes, and is it a best practice? I don't know, it's my practice. But I'm writing the style guide for the Angular team, and I think we just published a bunch of stuff yesterday on the style guide about how to do modules. So that one should be up there too. And the reason it should be in its own folder is if you're going to lazy load it, especially, it needs to know where to find the stuff. So you don't want to mix it in with other things.
Thank you.
Sure.
I have a question.
Go for it.
Just two quick questions. How does the CSS, when it gets scoped to the component, Angular actually transpile that CSS and like scope it? Each
Yes,
individual
Angular
class?
is scoping the CSS. So if you call a class foo, it's sticking some kind of weird ng class like in front of it to scope it to that particular component,
Okay, interesting. And
which you don't have to worry about.
Very cool. Next question is, how big, gzipped and everything, is a typical Angular 2 app?
We're still learning how big those things are. Like I know yesterday at Angular Connect in London, they showed a Hello World app, and I believe they purported it to be about 27K gzipped for a Hello World. I know Tour of Heroes, we just did it last night, so I was up late, and we were doing all that stuff. We were doing the tree shaking and the AOT, the ahead of time compilation, and I think the Tour of Heroes, we got it down to 100K gzipped, but that felt big to me. When I started looking at what was in there was stuff in there that I think I forgot to take out. So it really depends what you're doing. Like if you pull in HTTP and forms and routing and Angular material and other things, it's really important to tree shake and do the ahead of time compilation. Because you can take an app that's like 1.5 meg, and after you're done gzipping it, get down to like 100K. Sure.
I got a question.
Sure.
For the injector, how do you differentiate singleton versus new instance per?
That's advanced Angular. How do you differentiate singleton versus your own instance? There's actually conventions for it. You don't tell the service and the injector which kind to give you, like you do with like Unity or Ninject. But instead, if you want like let me back up for a sec. Let's say you had a data service to go get HTTP. There's no state in this service. It's just making HTTP calls coming back. You probably want a singleton, right? So with that, what you do is you put it in its own module. Like I usually create like a core module. My core module is something everybody gets. It gets it once, and it shares the same instance of all the services. That guy I'd put in there. And I only import him one place. So I import that core module in the app root module, so everybody gets it. If I then imported the core module somewhere else, which it already has it, by the way, but if I imported it somewhere else, what would happen is I'd get a new instance of that service. So it's not in how you define it, it's in how you import the modules. If you import a module that has a provided service, what's going to happen is you're going to get a second instance of these kind of things. So there's ways that you can actually go about it. This is actually defined in the style guide up on the Angular IO website too.
All right, thanks.
Sure.
Yeah, I had a question about the per component CSS. So how does that work? Is it basically like making a bunch of importance statements? Is that what it's doing?
No, it's actually creating its own tag. Like I forget what exactly it is. It makes up like a underscore ng foo class that it sticks in front of all those things on that page. So it's basically pre-processing your CSS, scoping it to the page so nobody else can actually use it.
Okay. When would you use that versus making your own CSS for that component and making it part of your main style sheet?
Is the question, when would you put it inside the component versus the main style sheet?
Yeah, or like its own CSS file that you import in another CSS style sheet.
Gotcha. So the way I look at it is, if it's something only my component's going to use, I put it in my component. If I'm going to promote my component, like make my own like date calendar widget, and let other people in my company share it, I'd put it in that component. If it's like application-wide color schemes, fonts, margins, padding, that kind of stuff, I stick that back at the main style sheet level. Like all of my company stuff, we put all our theming for our apps in the main style sheet, and we put all the component-specific stuff inside the component.
Okay, makes sense. Thanks.
Yeah. It does take some thought, though. You got to think it through, you know?
So I have one more question, sorry.
Yes.
ASP.NET, so...
What's that?
That's a good question.
Just kidding.
But with Azure, right, we are stuck with Visual Studio and...
You're stuck with it?
yes, of course.
Really?
Unfortunately.
Visual Studio is awesome.
Right. No.
You're going to get mugged outside
I'm
now.
talking about templates. Right? Just talking about templates, Visual Studio templates, right?
Yeah.
So which one would you recommend that we use? ASP.NET empty template or, you know...
Oh, gosh. I always use, as far as project templates, I use the one that gives me the least stuff. Because I can't personally stand creating a template and I have 90 files, and the first thing I have to do is go delete everything I don't want. So I usually go find something that's got less than I want, and then I add to it. It's my personal, so I don't carry any baggage along. Because what happens if I forget to delete stuff, right?
But do we need any of the ASP.NET functionality
To do Angular?
anymore?
Not at all.
Okay.
Angular is completely client-side. You'll need a server somewhere eventually, right? Well, I assume so. But if you're going to run off the server, my preferences are either Node or ASP.NET Core. So I do use those, but I usually put those, and I use them for their web API capabilities. I don't use them for generating the HTML. I use Angular all for that.
Sure. Thank you.
Sure.
I had two questions. One, you said that modules could be either eager loaded or lazy loaded.
Yes.
How do you specify that? And then the second question was, how do you do the ahead of time compilation and the tree shaking and all that you talked about?
So let me answer in reverse order. How do you do AOT and compilation? There's actually a cookbook that we're writing. There's a draft up there on the Angular IO website right now how to do it. Actually performing the AOT and the tree shaking is easy. The hard part is, if you're going to know in advance what something's going to do, you have to be able to deterministically figure it out. So that means that if I want to do ahead of time compilation, there's certain ways you have to code to make sure you don't screw up the compiler. For example, if you're going to go get a module, it should be able to figure out, I want that module. You can't have a function saying, give me this module or that module. So little things like that we're trying to document. Running it's easy. There's a guide up on the site for it. The lazy loading, I'll show you examples here. What you do is you say, when I go to dashboard, load children, and you point to a string that points to the module that contains the thing you're going to lazy load. It's got to be a string, because if you import it with a symbol, it's going to go import it and eager load it. So you have to give it the string name of that, and then use the hash sign to tell it what's the name of the thing inside of it that you want to load.
And so that's within the routes itself, not?
Yes.
Like, okay.
So the router inherently will lazy load for you.
Okay, thank you.
Yep. And if you didn't want to lazy load, you just do what I did down here for the bottom guy. You just say component, and that will import the guy directly. So if we go over to dashboard, I want to show you that example. Or actually, go to sessions. We've got him. You'll see his modules here. He's got his own routes. You'll notice the sessions module that I've got here isn't imported in the other guy. It's just referenced by that string. It's actually super easy. If you ever did lazy loading in Angular 1, it was like weeks of pain and anger and tearing out your hair. In Angular 2, the first time I tried it when they coded it, it took me less than 5 minutes. And that was mostly because I didn't believe it was going to work when I pressed run. So that was pretty cool.
We have an application that queries SharePoint, and so we have a service.
I'm sorry.
We have a service that is doing those queries to REST endpoints in SharePoint
Yeah.
and getting back data. And a lot of those methods in our service that are getting that data, sometimes we'll pass information, and so the shape of the JSON that returns is different. My tendency as kind of a C# background, I want to kind of wrap that, what got returned, into an object that then all of our components use.
Yep.
So it knows the type, and TypeScript is actually
Like
doing
a
something.
mapping of the JSON
Yeah.
to an object.
Yeah. But on one hand, that kind of feels wrong because it's kind of a dynamic JSON object that changes based on what we passed it. But on the other hand, I don't want object getting passed everywhere throughout the app, and I didn't know if there's any patterns or recommendations for that kind of thing.
There are. I kind of lean towards, I don't bother putting the thing into an object unless I need to. But there are times I do it. So for example, I created a vehicle in a character class, and then when I got back my JSON, I actually mapped it into there. This gave me some advantages because I got strongly typed properties in my project. If you're not actually going to instantiate the class, though, sometimes I'll create in TypeScript, they have a type. You can create your own type called character or story or customer. What that does is it doesn't generate any JavaScript, but it gives you the type safety when you're writing your code. So that's the advantage of I'm not generating things I'm not actually using. But so you can use types or interfaces or classes to do this. And I wouldn't use any library to do it. I would just take the data that comes out of your HTTP call, take the JSON, and map it into your class. Usually call like a constructor function or something and pass it in. But I do that too. I usually have like a models folder in my project that everybody shares. Yep.
Hi.
Hi.
We are developing an application using Visual Studio Code and CLI for build on the RC4. What is the best way to migrate this to the release version?
RC4.
Yes.
So RC5 is when they introduced NG modules.
NG model, yes.
Yeah, have fun. When they introduced modules, that was probably my biggest pain with Angular. It was 2 years I've been doing Angular 2, and the biggest, hardest conversion I had was when I introduced modules. Because now, you didn't have any in your app. Now you've got to go back and stick them in. There is no easy way to do it, honestly. You just have to go create the modules and use them. The good news is, though, now that they're unreleased, future versions of the CLI, part of their roadmap is, okay, you're on version 2.0 of Angular, now you're on 2.1. They're going to make the CLI help you upgrade to look at your project and do it.
But
right now,
not in the
no.
near future, right?
That's the future.
Okay.
They're not doing that for RCs and alphas and betas.
Okay. So are they working on the CLI to do that upgrade?
Yes. Actually, they never stop working. I'm on a Slack channel with these guys, and that's all they do. And the reason I talk to them a lot is because as I'm writing the style guide, they're trying to make sure the styles that I've put in the guide are following the same things they're doing in the CLI. So all the naming conventions you're seeing in this app, that's the stuff you're going to see in the CLI.
Any timeline, about it? Any timeline on
For the upgrade stuff?
Yes.
No, I just know it's on the roadmap right now. They're trying to, the CLI is not released officially yet.
Yes,
I think
it's in beta
RCO
14.
or something came out today.
It's in beta 14.
Yeah, and RC0 comes out today.
Yeah, okay.
I hope I didn't announce that, but yeah.
Thank you.
Yes. We have 5 minutes. We're cool.
Sure. My company has a web app that currently uses Angular Translate with Angular 1 to serve up German and Spanish versions of our pages. Are there any tips or gotchas in using it for Angular 2, or is it just pretty much the same thing but with first-class citizenship now?
So Angular Translate, the stuff that Pascal Precht wrote for Angular 1, was awesome. He didn't write it for Angular 2, but instead he's working with the Angular team, and they are writing their own I18N library. So there's an I18N module for Angular 2 that you can use. I haven't used it yet, but last night one of the documentation guys was actually writing a cookbook on it. So I imagine within the next week you'll see something on the website on how to do that.
Okay.
Yep.
Thank you.
By the way, you know why it's called I18N? I didn't realize this for a while. I18N means it's a 20-character word, and it starts with an I and ends with an N. There's 18 characters in between. So I'd be J2N.
Yeah, quick question. Can you bring up your definition of just any of your custom components so I can ask you about it?
No.
Please.
Was that the question?
No, well, that's
I'm sorry.
Okay, yeah, that's good, that's good.
The code or the HTML?
That right there is good. You have a component definition that's followed by export. I can't, maybe I missed this, but I can't see what relates one to the other and what ties them together.
This guy to this guy?
Yes.
So have you done .NET, C#?
Yes.
Okay, so in C#, which is not going to like in here, I would do class fool, like this, right?
Right.
And up top, I might call this guy, oh gosh, I don't know. He's a component now. So that's what I would do in .NET, right? This is the same, but just syntax over in there. The thing is, component is actually a function in .NET too, and you can pass parameters in like A and B and et cetera. So these are just parameters we're passing in.
Okay, all right.
So it's really just like that.
Okay, all right. Second thing, does Angular 2 provide any kind of type checking? For example,
TypeScript does, though.
Oh, okay.
So by using it with TypeScript, the nice thing is as you're typing stuff in, so let's say I deleted this whole file, oh my gosh, and I come through and I can use a snippet, which I've written some snippets. As I'm typing in things, like inside my guy, I could have a property called, let's say, hero, and I'll just make him an array. So, oops, equals. If I come down to my constructor now and I say this dot, notice the type checking comes up in IntelliSense and all that fun stuff. We can do that on Angular features too. So I could come in here and I could say, okay, component dot, and I can see all the properties on component because that came from Angular.
Okay, yeah, but I meant if I have a RESTful service that returns an object, I want to verify that what I got back is what I'm really expecting.
Yeah, that's what you do inside of the mapping of your subscription in your HTTP call. You'd say, give me my JSON, and I would map it to a class that I create and make sure that those properties exist and can map in. So it's the same thing we did with .NET, where if you had an HTTP call, you don't have the class, you have to map it in yourself, unless you use like a mapping library to do that.
Okay.
Yep. Unless you use WCF, which I don't do anymore.
I have a question. How well or how bad Angular would coexist with MVC or Razor files or it's not recommended at all to have them together?
How well will Angular 2 work with Angular MVC or Razor files? So there's a couple, let me give you my personal opinion. With Angular 2, you still need a server to serve the code and to do web API calls. So ASP.NET Core is wonderful for the web API calls. Awesome. I personally don't use Razor with Angular 2, not because you can't, but because I don't like splitting my paradigm. Meaning, now I'm rendering on the client, but I'm also rendering some of it on the server, and it kind of feels weird to me. But you can do it.
So you would recommend to leave .NET to web API?
I would just do the web API with .NET, yes, and do the Angular on the client. Cool.
Okay.
And we just ran out of time, but I'd be happy to talk out in the hallway too, if any of you are interested. Thanks.